All right, so today we are going to do representing a function as a power series. I'm going to go over this again because number one, it's worth it, and number two, a bunch of you were absent last time. Power series is a general word that simply means you're representing a function as an infinite series. Within that, a Taylor series uses that pattern that you just took the quiz on, right? That specific pattern. And within Taylor series, Maclaurin simply means it's centered at 0. But power series is just a general term for, we're representing a function as a series. Like if we take the series out forever, it will not approximate the function. It will literally be the function. So what we're going to do today are a lot with geometrics. So let's review our geometric pattern. This is what it looks like in the sigma notation. Summation from n is 0 to infinity, a times r to the n. Does it look familiar? Went that long ago. And that sum is a over 1 minus r. And in order to converge, your absolute value of r has to be less than 1. Okay, so what we're going to do is force all of these to look like that. Do we have good algebra skills? Well, we're about to find out because that's what this is going to be, is a whole big bunch of algebra. We have to force it to look like that. So steps. Number one, you make sure, or can't talk. You make sure that it is centered correctly. So you want to make sure that it is centered at whatever they tell you to center it at. All right. Secondly, we're going to make sure that r is subtracted. Do you see how in the formula it's 1 minus r? If that's plus, we need to fix it with a negative. All right. And then the last thing, it has to be 1 minus r. So if it's 5 minus r, that's not good. You have to change it to a 1. 7 minus r, that's not good. You have to change it to a 1. It has to specifically be 1 minus whatever that r value is. So we're going to just do some algebra to get them centered correctly and make sure the 1 and the minus are there. And then we can write out our power series. I started with a super duper easy one. Okay. Centered at 0. Do you see how it's just x or x minus nothing? So is it centered correctly? Mm-hmm. Yes. Is it subtraction? Yes. And is there a 1 here? Yes. So I made the first one like already set up for you. Okay. Oh. Like, so if it was centered, like on your quiz, when it was centered at 1, in your parentheses, what did you put? X minus 1. If it needed to be centered at 3, what would you need in your parentheses? X minus 3. Do you get what I'm saying? Okay, but this one's 0. So A is whatever's in the numerator, which in this case is 1. And R is whatever got subtracted there, which in this case is X. Okay, so we're going to write out our series, our power series. So it is A times R to the N. I put the 1 in there. I like to do that, again, because it's just a pattern. If you're like, no, I don't put the 1, then fine, And then I'd like for us to list out at least the first 4 terms. Typically, that's what you get asked for, is the first 4. So the first one is obviously just 1. And then you just keep multiplying by x to generate the pattern. That r value is x. Just keep multiplying by x. So 1 times x is x. And then times x again, squared, and times x again, x cubed, and plus, infinitely number of terms. And if you go out forever, it represents this function exactly. Do you see what we did? Like, do you understand what it is? Yeah, I'll see you. Have a good day. All right, so let's try another one. This one is not centered correctly. I want it centered at -1. So what should we have in our parentheses? X plus 1. Okay, so what I usually do is off to the side, I'm going to take what we started with and write an equivalence statement. I'm going to mess with this, but we can't change it. They still have to be equal. Still has to be equivalent. So I'm going to put 1 in the numerator. That's not going to change yet. I'm going to leave a little blank here because it's not going to be a 1 anymore. That's going to change. So like leave a little space. And what did we just say we wanted in our parentheses? X plus 1. Okay, so what you have to figure out is what number needs to go here so that it's not any different. You have to maintain the integrity of the problem. I still need it to be algebraically 1 minus x. Good. Why would a 2 go there? Because that is correct. If you were to distribute this negative, you would have 2 minus x minus 1, which would then equal 1. Okay, cool. We're on board. So we did step 1. It's centered correctly. What is step 2? Good. Is this minus? Cool. That's good. We don't have to do that. It's already set up. What's the last step? It needs to be 1 minus r. It's not. It's a 2. So what we're going to do is divide this by 2, divide this by 2, and divide this by 2. You have to divide everything. Remember, in algebra, everything is fair. It's like what you do to one side, you have to do to the other. So what is our numerator going to be now? It's 1/2, and then it'll be 1 minus x plus 1 over 2. That doesn't change where it's centered, if you were worried about that. It's still centered at -1. We just took that and divided by 2. So we've done all 3 of our steps. We're going to list out what is A, what is R. 1/2, good. And R is perfect. And now we're going to write out our sigma notation. And I like to do the first 4 terms in your series. They're like little algebra problems. It's like little puzzles. All right, so we're going to start with 1/2, and then it's times that R value to the n. That's just how that gets written. It's A times R to the n. And I want to list out the first 4. Yes?
You always series that 0.
Geometric will, yes. That's almost sort of like a by definition thing. Those ones always start 0. All right, so the first one's 1/2. And then you're going to just keep multiplying by x plus 1 over 2. So the next one would be x plus 1 over 4. Good job. And then you're going to multiply that by x plus 1 over 2. So it would be x plus 1 squared over 8. Good, and let's do one more. X plus 1 cube. Perfect. Forever and ever and ever and ever. There's a sign that says this door is going to stay locked. So I know what to tell them. All right. Let's write this off to the side. When I write this, though, instead of in the denominator x plus 2, I'm going to choose to write 2 plus x. That's going to help us. I want the x part to come second. That's going to turn into what's r. So step 1, is it centered correctly? We want to be centered at 0. Yes, it's x minus nothing. All right. Step 2 is what? It needs to be subtracted. Here is the easiest way to do that. You see what I did there? Okay. So that's the easiest way to handle that. Yes. I didn't want to interrupt them, though, because they're talking about the previous problem, which I don't like to interrupt those conversations because those are good. But yes, okay, step 3. Some of you said it already. We need for this to be a 1, so we're going to divide this, and this by 2. So the numerator, 4 divided by 2 is 2. That turns this into a 1, which was kind of the whole point. And then this will just be negative x over 2, or negative 1/2 x. You aren't wrong. There's so many different ways you can write things. No one's right, no one's wrong. However you want to write it is fine. All right, so what is A? 2. And R, interestingly, is, what does that mean our pattern is going to do? Perfect. They're so smart. Yeah, these are all geometric. All right, so sigma n equals 0 to infinity. It's going to be 2 times negative x over 2 to the n. Again, that's just how it's written. That's the pattern for geometric. And I want us to write out the first 4. 2. And you're going to multiply that by negative x over 2, which would actually just be negative x. And then you're going to multiply that by negative x over 2, which will be positive x squared over 2. Perfect. And you're going to multiply that by negative x over 2. So negative x cubed over 4 plus forever. Sweet. Hanging in there? Doing okay? All right. For this one, I'm going to take this and write it off to the side. Instead of 2x minus 3, I'm going to write negative 3 plus 2x. You want the x part to come second because that's what's going to turn into the r portion of what we're doing. So the first thing to do is to center it correctly. We want it centered at negative 3. So in the parentheses, I would need x plus 3. Good. And I left a little blank there because we're going to need to figure out what number goes there, again, so that we don't change it. If you distribute this 2, you're going to get 2x plus 6. But I need it to still be a negative 3. So what would go there? Negative 9. Good. I heard a few of you say it. You just weren't very confident, so I was giving a few other people a chance to answer. If you were to distribute, it would be negative 9 plus 2x plus 6. Negative 9 plus 6 gives you negative 3. Cool. All right, what's the next step? We got it centered correctly. Now what? Not yet. That's step 3. You skipped step 2. It needs to be minus. Okay, so what's the easiest way to fix that? Yeah, minus a negative. And then what you guys just said was correct. We're going to divide everything by negative 9. We're going to divide this by negative 9, this by negative 9, and this by negative 9. Everything. So the numerator will now be negative 5/9. Don't worry. We're done with the problem at this point. That's just going to be your a value over 1. That was the whole point. Minus. Now, if you divide this by negative 9, yeah, it will be 2/9 times x plus 3. Which, again, just is what it is. That's what it came out to. Sometimes things get messy. All right, so A is negative 5/9. R is 2/9 x plus 3. I'm just pausing there for a second to let it marinate. I hear a lot of you writing, though. If you're going ahead of me, that's fine. We divided by a negative 9.
But you don't divide the x plus 3 by 9 because...
Oh, well, it's because it's part of this. This is all part of the same thing. We technically did. If you want, so if personal preference, if you choose to write it like this, that's fine too. Does that sit better in your mind? Because again, like you can write it, it's how your brain works.
Yeah, I was asking if the 2/9 distributed.
Yes, if you distribute it, it would equal that. So again, I wrote it the way that it makes sense in my brain. If we're different, that's okay. All right, we can write it differently. Are you all right?
Oh yeah.
Stop dying. Yes. Hold on, let me pause this and answer the phone. Okay, so inside of our sigma, what's going to get written first? Yeah, negative 5/9. That's our a value, and then times. Yeah, here, you know what? I'll write it this way. That might actually be better when we go to multiply it out. Means the same thing. I think we're only going to do the first 3 terms in this one because the numbers are going to get sort of large when we do 9 times 9 times 9 times 9. So let's just do the first 3 this time. The first one is just negative 5/9. Oh, it's a bad 9. Let me fix it. All right, and we're going to multiply that by 2x plus 3 over 9. So if we multiply the numerator, actually every term is going to be negative here, which is interesting. It's not going to alternate. They're all negative. It would be minus 10 x plus 3 over 81. Good. And then minus again, every single term is going to be negative. Let's just do one more because, again, the numbers are going to get sort of large here. We're going to multiply this by 2x plus 3 over 9. So it would be 20 squared, good, over 81 times 9, 729. I don't feel like multiplying that by 9 again, so we'll go ahead and leave it there. And then one more. Or do you want me to pause and you can try the last one on your own and then we'll do a I got this, what did you get? Let's try that. Okay, the first thing we're going to do is center it correctly. I'm going to leave a gap here. What do I want in my parentheses? X minus 1, but I need for it to still technically equal X. Like I'm not allowed to change that. So what would I need out front? A 1. Okay. So the only thing that's the matter here is what? What's wrong that we need to fix? Yeah, it needs to be subtraction. So it's going to be 1 minus negative X minus 1. I was listening to you guys, and can I just talk about what you were saying with yours? If you distribute this, you would get what? Negative X plus 1. Can you see that it's centered correctly then? So you probably should write it. That is kind of a thing where like this is righter than that. Yours isn't wrong, but you can't see where it's centered if you distribute the negative sign. Okay, so anyway, are we good? We have it centered correctly. We have subtraction and we have 1. Okay, so what is A? Yeah, 1. R is negative X minus 1. So I was saying no. If you distribute it and you get this, can you see easily where it's centered? No. So it's not technically wrong, but you should really, that is a case of like, you probably should write it like this because you want to be able to look at it easily and see that it's centered at 1. Okay. This isn't wrong. All right. Sigma n is 0 to infinity. 1 times negative X minus 1 to the n. And then let's just list out the first 4. I wrote kind of big, so I'm going to come down to the next line. Our first term is 1, and we're going to multiply that by negative X minus 1. And then we're going to multiply that by negative X minus 1. So it's going to be positive X minus 1 squared. And then the next term would be negative X minus 1 cubed. So I think writing it that way also makes it easier to expand because let's just do it verbally. What would the next term be? Positive X minus 1 to the 4th. And you can see it a little bit easier.